Hi everybody, today we are talking about exponents with integer bases and negative fractional bases. As a reminder, you do not need to write down everything in this video, but be sure to jot down important information and at least one example of each type of problem that we cover. Remember that you can also pause the video to jot down important notes, rewind the video to view information again, and fast forward if you think you got it. But just be careful and make sure that you didn't fast forward too much that you miss out on something important. So let's begin. Let's just review what exponents are. Remember that exponents show us repeated multiplication. The base number is that normal size number that is being multiplied by 1 and itself again and again. The power, that little number on the top right-hand corner, tells you how many times you're actually going to multiply. So for example, with the base of 3 here, if it were 3 to the 5th power, it would be 1 times 3 5 times, which will get you 243. Remember that to the 3rd power has a special name, cubed. To the 2nd power has a special name, squared. Anything to the 1st power is really just 1 times itself, so it's going to stay that base number. Any number to the 0 power means that 1 is not being multiplied by any value, so it stays as 1. It doesn't mean 1 is being multiplied by 0, because 0 is a value. So it's just 1, and it doesn't do anything. So it maintains that value of 1. Today we're talking about integer bases. So far we've talked about natural number bases. So we haven't given negative value to the bases. Remember that integers are any positive and negative whole numbers. So today that's why we're talking about negative numbers in the bases. So exponents with integer bases. We're going to talk about two different situations. We're going to talk about the negative on the inside and the negative on the outside. What do we mean by that? Negative on the inside, if you notice, there's parentheses around the base number. This base number is negative 3. By putting in the parentheses, this problem shows us that the negative belongs to the 3. The negative 3 is going to be multiplied again and again. So wherever you see the 3, that negative is tagging along. When we talk about negative on the outside, we're saying that there isn't a parentheses, and that negative doesn't belong to the 3. That negative is kind of like hanging out on its own at the end. So when you have negative on the inside, and it means that the base number itself is negative, it gets very tricky because the sign is going to repeat, and then it's going to either keep the sign at the end as positive, or it's going to change the sign at the end as negative. The trick to remembering this is to look at the exponent, the power. If the power is even, so like 2, 4, 6, 8, this one is 4, that means that those negatives will pair up with each other. So these two make a pair, and then the last two make a pair. Remember, when negative is being multiplied by negative, it becomes positive. So as long as your negatives can pair up with each other, then at the end you're going to still end up with a positive answer. That's if it's an even integer, an even power. If you have an odd power, like this 3, then that means only 2 of them will pair up and you're still left with a negative, which will change your answer to a negative. For negative 3 to the 2nd power, these two pair up and those signs cancel and become positive. For negative 3 to the 1st power, this negative is alone, it doesn't get paired up, it gets moved on to the final answer as negative. So you're looking for pairs. And then negative 3 to the 0 power, that 1 wasn't being multiplied by any value in particular, so it just stays 1. Any number to the power of 1 is still equal to 1. So here, when the negative is attached to the base number, the even or oddness of the power will tell you if it's going to be positive or negative at the end. If all the signs pair up, then it becomes positive. If one is left behind, it's going to get scooted over to the final answer. Now, when you have a negative on the outside, it's a little different. So in this case, if it's negative 3 to the third power, it means that this 3 itself is positive. That negative doesn't belong to it because it doesn't have a parentheses. So what it looks like in expanded form is that it has the negative attached to the 1, and the 3's are maintained as positive. So 3 times 3 times 3 is 27 normally, but since we have a negative in the front, it becomes negative 27. Same thing here. If 3 to the second power normally is 3 times 3, 9, and then you tag that negative in the front, it becomes negative 9. Because the negative and the 3 don't follow each other. They're separate. Negative 3 to the first power is negative 3. And then the tricky thing here with the 0 power is that the 3 isn't being multiplied to the 1, but there is a negative sign. So it does change that final answer not to a positive one, but a negative one. So you can't ignore that negative here. In the previous one, the negative and the 3 were attached to each other. So since this base number wasn't being multiplied by 1, that negative doesn't appear in the answer because it belonged to the base. Here, it doesn't belong to the base. It's still there, and it has to appear in the answer. Make sure in your notes that you have the difference between these two types of problems. If it's in the parentheses, it's going to change the answer to either positive or negative. If it's outside, if it's hanging outside, it means it's definitely going to make it to the answer. The last type of problem we're going to go over is exponents with negative fractional bases. So far we've just had base numbers that were whole numbers, either positive or negative. Now we're talking about fractions as the base number. So in this case, we have negative 2/3 as our base number. So that means the quantity of negative 2/3 cubed would be 1 times negative 2/3 times negative 2/3 times negative 2/3. So that makes it 3 times. The first thing we're going to check is the sign. I have 1, 2, 3 negatives. That means 2 of them are going to pair up and become positive, but then 1 of them is still here. So the final answer is negative. For fractional bases, you're multiplying the numerators together and then the denominators together. It's almost like there's 2 different problems going on. So 2 times 2 times 2 is 8. 3 times 3 times 3 is 27 on the bottom. So it's the same thing as negative 2 to the third power and 3 to the third power. So it's like both of them got the powers separately. Similarly, the quantity of negative 2/3 to the second power, it's 1 times negative 2/3 times negative 2/3 twice. Those two negatives, since it's a even power, they cancel each other out and makes the final answer positive. And we have 2 times 2 on the top for 4, 3 times 3 on the bottom for 9. And everything else is pretty much the same. Here the negative is attached to the base number, so it doesn't appear in the final answer. If the negative were outside and not attached to the 2/3, then it would still stick around and make the final answer -1. Make sure these 3 types of problems are in your notes. We're going to end with a couple of examples on Khan Academy. All right, so here is an example from Khan Academy. They want you to evaluate this problem. Evaluate is just pretty much a math term, and it just means to solve for the answer. So whenever you see evaluate, it just means they want you to find the final answer. This problem is asking you to find the value for -7 squared. So go ahead and pause the video and see if you can solve it yourself. All right, so in this problem, I noticed that the negative and the 7 are not together. If they were together, they would be together in parentheses. and then that would be the negative tagging along with the 7 the whole time. But this is not it. This problem doesn't have the parentheses. So what we need to do here is make sure they're not together. The negative is going to be at the end, so let's give it to 1. And then the 7 is acting alone. That 7 is squared. So each time we have a positive 7, and it's being multiplied 2 times. Okay, so our final answer is going to have that negative, because that negative needs to be added to the end. And then we have 7 times 7, which is 49. So this answer is negative 49. All right. Again, that negative doesn't follow the 7. If it were to follow the 7, it would have to be in the parentheses. And then this answer would have been positive because these two negatives pair up to become positive, and it would be positive 49. So be very careful that you're reading and solving the problem correctly. These two answers are very different from each other. One is positive and one is negative because one gave the 7 the negative sign and the other did not until the very end. Go ahead now and try this problem on your own. Pause the video. All right, like the previous problem, we have to pay attention to who this negative belongs to. This negative belongs to the 10. They're both in the parentheses together. It's like the parentheses is saying, hey, these two belong together, don't separate them. So when we expand this, it becomes 1 times negative 10 is together times another negative 10 because it's to the power of 2. So we have to make sure there's 2 of them. Okay, negative times negative, they paired up, so it becomes positive. Your final answer is positive. 10 times 10 is 100. You don't need to type in that positive in the final answer. I'm just putting it there to remind myself. All right, so when the negative is attached to the base number, you're going to have to pay attention to whether it's going to cancel each other out or not, because then you have a whole bunch of negatives and you need to start simplifying and seeing what it does in the final answer. So that's exponents with integer bases. Let's work on some examples with exponents with negative fractional bases. This one is very interesting. We haven't covered what to do when you have a mixed number as your fractional base. So go ahead and pause the video and see if you can solve this on your own first. All right, for this problem, we notice that the negative and the base number are together, so they need to stick together. So it becomes 1 times, and then that negative is going to appear with that base number. 2 times, because there's a power of 2, 1, 2. Notice that I didn't write negative 1 2/3 in there. I left it blank, because we actually can't do this. When you're multiplying mixed numbers, you actually have to change it to an improper fraction first. Okay? You want to make sure that you are multiplying your numerators by your numerators, denominators by your denominators, because multiplication doesn't work out when you multiply your mixed numbers together. All right, so let's go ahead and do that then. Remember, we need to have improper fractions. So let's erase this, and let's make sure that we have improper fractions inside. 1 2/3, if I were to draw it out, it would look something like this. 1 whole, and then 2/3 shaded in the second part. So this entire whole, and then 2/3. 1 entire piece and 2/3 pieces. So how do we figure out the improper fraction? Well, these are, split into 3 pieces. So this whole would also be split into 3 pieces. So in total now we have 1, 2, 3, 4, 5. 5/3. This entire 1 was 3/3. And then we were adding in the 2/3 here to get the 5/3. That's basically what improper fractions are. We're basically taking that one whole, changing it into a fraction, adding it to the leftover piece. The shortcut is what you probably learned before, is that you multiply 1 and 3, and then you add 2. 3 times 1 is 3. 3 plus 2 is 5. 5/3. Okay? Because they're cut up into 3 pieces in one whole, so 3 times 1 is 3 of those pieces, plus the leftover of 2. So in total we have 5 pieces of the thirds. So this is 5/3. When we multiply them together, we see that we have 2 negatives, which become positive. So our final answer is going to be positive. And then we multiply our numerators. 5 times 5 is 25. 3 times 3 is 9. This is an improper fraction. If I were to put it into Khan Academy, I want to make sure that they can handle improper fractions. It says your answer should be a simplified proper fraction, like 3/5, or a simplified improper fraction, like 7/4. So they said that they will take improper fractions. So I can put that in as my answer and they will accept it. Okay, so you want to make sure that you read that. If you want to change it into a mixed number, you can totally do that. You would take the top number divided by the bottom number. So 9 goes into 25 2 times. 25 minus 18 is 7. So we end up with 2 and 7 ninths. Okay? If we were to keep it, going back to my point in the beginning, how you cannot multiply mixed numbers, if we were to multiply these two together, it would be 1 times 1 is 1, 2 times 2 is 4, and 3 times 3 is 9. 1 and 4 ninths is not the same as 2 and 7 ninths. This is wrong. See how it just doesn't work? You kind of have to change them both into improper fractions and then multiply. Just multiplying it straight across as a mixed number just doesn't give you the proper answer. So be careful. You definitely have to change it into improper fractions before you multiply. All right, here is one last problem. Go ahead and pause the video and see if you can solve it yourself. All right, in this problem, the negative and the 4/3 are together. If we were to expand it, it would become 1 times negative 4/3 times negative 4/3, and one more time, because it's a power of 3, times negative 4/3. Here I notice I have an odd power, so that means one negative is going to be left alone. Here these two become positive, and I have an odd man out. So that means my final answer is going to be negative. For my numerators, I'm just going to multiply 4 times 4 times 4. I can do that in my calculator or my head, and that's 64. The denominator is 3 times 3 times 3. That's 27. Remember, Khan Academy can handle improper fractions for these ones, so I'm just going to put that in as my answer. Negative 64/27. And there we go. So the hardest part will probably be the sign and remembering the different rules for the integer and fractional bases. Let me know if you have questions as you work on these. If not, I will see you in class.